When we used to write y equals x squared, we say, what's the graph of that? That's a parabola. Which way? It looks like this. If you see in y equals negative 2x squared, that's a parabola. Concave down. When we used to write x equals 3y squared, that's a parabola going which direction? To the right. X equals negative 5y squared. Well, I'm not sure how narrow it's going to be. That's the problem. How narrow, how wide that graph, because all of these are parabolas going to the right. All of these are parabolas going to the left. All of these are parabolas going down. These are parabolas going up. So how do we know which one of them, how tight, how wide the graph is? And we're going to give you a little tip on that, and we're done. Now notice if you have y equals, it's going to be either up or down. If you have x equals, left or right. Notice the difference between parabola also and a circle. A circle, both x and y were what? Squared. The parabola, only one of them is squared, the other one is not. Only one is squared. In this case, y is not squared, but x is. Here, x is not, but y is. Now, how do we know how tight the graph is? I'm going to look at these first. I'm going to look at these one, left and right first. That means the y is the square, not the x. Then I'll go back and look at these where the x is the square. So let me look at these. If I have the standard form for a parabola, the standard form is y squared equals 4px. 4px. We said y is the squared. So if p is positive, it's going to look like this. P is greater than 0. And if p is less than 0, negative that means, is going to be pointing in the opposite direction. Now, what is p going to do for me? Let's say for this example, let's assume that p is 1 for the sake of this discussion. P is this point, which means if this was like a salad bowl, shiny one, and you take a flashlight and you shine the flashlight at that salad bowl, all the beams will deflect through that point. That's the point. That's what P is. It's called the focal point. Who cares about the beam? I really don't care about the beam. What that's going to tell me, say at distance P, there's a line that goes up and down here. And that line has a name, it's directrix. Somebody asked me if DirecTV came from that name. I said, I don't know, could be. Couldn't tell you yes or no. Because you can actually, parabolas are used in these dishes. If you have a DirecTV, there's a receiver there, and that receiver got to be in that point when the beams hit that dish. You want them all to deflect through that point. That's where the receiver picks the signal. So if on a snowy day, if this is covered, you're not getting a signal. Or if somebody goes and moves that, you knock it, move it, you're moving something and you hit that one, suddenly it's right here, you're in trouble. You're not getting that signal. So what's the significance of that directrix? That tells us how actually sharp the graph is. How? If you pick any point on the graph, any point, the distance to that P point and the distance to this has to be the same. Now looking at that picture, does that look the same?
No.
No. So that means probably has to be wider. Maybe the graph should be a little bit wider, like this. So if I pick a point like this, measure the distance to this line and the distance to this, does that look the same? Close. So that's how you can gauge actually how tight the graph or how wide the graph is. That distance has to be the same. So here's an example. Let's take this one. I want to graph y squared equals 4, what is it, 12x, I'm sorry, 12x. Let's compare it to that one. Y squared equals what? 4px. That tells me what? 4p equals what? 12. 4p is 12, which means p equals what? 3. One, two, three. That's where the focal point is. The directrix is going to be what? 1, 2, 3 back. It's going to be up and down like this. X equals -3. Has to be, the distance from here to here has to be the same distance from here to here. How am I going to find how tight the graph is? I don't want to be guessing here. Let me take a pencil so I can erase it. I'm going to erase this. So if I go, well, let's try this. Just a wild guess. How about this? Can you see that on TV? Let's pick a point on that. Is that point to this the same as that point? No, not even close. Well, what about this one? If I go this, is that distance to F the same as this point? Close. Yep. So I don't want to guess on that. Nope, I came up with my own solution, being an engineer. Yep. What's the distance from this point to this point?
6.
6. There we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's what the graph is. Why? Because if you pick that point, how far the point to this? 6. How far to that line? 6. It's supposed to be the same distance.
Wow.
So that tells me the graph is going to be this wide. So instead of guessing, I go twice p up from that point, straight up. And that'll be actually, I get the 2 points, and that's what my graph is going to be. Now that's not in the book, that going up 2 steps. Because I used to do it before, guessing, let me try this, let me try that, try to guess. Then I came up with this idea, like, what am I guessing? It has to be a way to do it. That distance is going to be twice that if I go this way, and that has to be the same thing. So I do them that way. Let me try another one. That's the whole thing about parabola. I have y squared equals -8x. What's the standard form? Y squared equals what? 4px. That means the -8 has to equal to what? 4p? What's p equal to? -2. Since it's negative, it's opening to the left. minus 1, minus 2. So minus 2 comma 0, that's your focal point. Right here. So the distance from the origin to that point is what? 2. So I'm going to go back 2 more steps. And there's my directrix. My directrix right here. That's x equals to what? The equation for it? 2, right? Now to graph it again, I'm not going to guess. The distance from the focal point to this line is 4 units. So let's go up 4. 1, 2, 3, 4. 1, 2, 3, 4. The graph should look like this. Measure that distance, 4. Measure this distance, 4. So there is a parabola going to the left. Let's do 2 up and down. Then we out. So when it's y is the squared one, it's left and right. When x is the squared, it's up and down. So for up and down, x squared equals 4py. I don't know if I wrote that early. Did I? Nope. So when it's up and down, if I have x squared equals 4py, when pi is greater than 0, it's going to open upward. When p is less than 0, it's going to open downward instead of left and right. X squared equals 4y. The standard form, x squared equals 4py. 4 equals what? 4p, what's p equal to? So it's opening upward. This is the focal point. What's the coordinate for that? 0, 1, right? X is 0, y is 1. It's 1 unit straight up. Here is the directrix. What's the equation for the directrix? Y equals what?
2p.
Nope. For this line.
Negative 1.
Negative 1. It's below the x-axis, right? So now to graph it, we know p is 1. So from this point now, I'm going to go 2 to the right and 2 to the left. And that's the graph. Notice that distance here, if you measure that, that's 2. If you measure this, that's also 2. I don't know if any of you seen this summer I did a suspension bridge with the high school. Tyler was in the class. We built that bridge, and that was the big event. Everyone still talks about on campus. We built actually a 16-foot suspension bridge. And what I did with it, when we got some wood, we actually were strong enough that we all walked on it, including the president. So let's say you want to build a bridge, the Golden Gate Bridge. This is, we get to see what engineers do. This is the ground. And usually that bridge is suspended, let's say, it says couple of beams here for support beam. Another one here. And you have these cables You know, don't like that. And before they deliver the cables, actually, everything was pre-cut. When we actually did ours, we were in the classroom, we measured all these cables. We said, okay, I know how wide that bridge is going to be. So for this example, the width of the bridge is going to be 4,200 feet. That's from here to here is 4,200 feet. The deepest point is going to be 300 feet. That's down here, 300 feet. I want to find the equation that describes this one. Why? Because if I know that, and let's say I'm going to put every every 200 feet I'm going to put a beam. There's 200. There's a 400. There is a 600. Whatever the case is, if we know how far we're going to put them, I can pre-cut these beams. So when they show up to the site, everything was pre-cut. So what I need to know is figure out what the equation of this line is. That looks like a parabola concave and upward. And what do you know? If it's a parabola concave and upward, the equation for that should be x squared equals 4py. So to be able to use that, all our parabolas, where was the center? At the origin. See it? And it's symmetric. So to do that, to make sure that fits that criteria, I'll put my x-axis right here and my y-axis right there. I said them backward. X and y. So I need to know the equation. So I need to know what P is. If I know what P, I have the equation that describes that bridge there. Well, wait a minute. If we know one point on that line, any point on that line, you'll be able to solve for P. Because if you know X and Y, how many unknowns left in that one? Just P. Do we know any points on that line? We know that point, right? What's the X value for that? Exactly, half that number. And what's the Y value? What's the Y value? 300. So plug it in. X is 2100, Y is 300. $2,100 squared equals what? 1200 P. What is P equal to? That's what we did on that bridge when we talked about it actually in the classroom. What is it? Yeah, but you divide by 1200, you end up with 3675. So the equation that describes that bridge now, the equation that describes that bridge is going to be x squared equals 4 times, in place of P, 3675 Y. X squared equals 14700 Y. You tell me where you want to put these beams, and I'll tell you actually how tall they should be. 200 will be too short of a beam. Let's put like a 500. We're going to put the first one at 500. It's going to be a matching one where? A negative 500, probably symmetric, right? We're going to put one at 1,000. Negative 1,000. So let's see what will happen when we have the 500. That's x. X is 500. I want to solve for the height, so when it comes to me, it's pre-cut. Just got to put the screws in, tie the cable on the top, ready to go to the next one. 500 squared equals 14700y. What's y equal to? That piece has to be 17.007 inches, feet, yard, whatever unit we're using, feet. So 17 feet tall. It's going to be one here and one there. The next piece, how far is it from the center? 1,000? 1,000 squared equals 14700y. Can we get what y is? That's 1 million divided by 14700. 68.03 feet high. Two of them, one on each end. The next piece, the next piece, the next piece. So when the pieces show up, that thing is done. This is a true story. 2 months ago, a 4-lane bridge, 4-lane highway, was built in 3 days. 4-lane highway bridge was built in the U.S. in 3 days. Everything was pre-measured, cut, ready to go. The foundation were poured in, they came in, blew the old one out, grabbed the first piece, screwed in, next piece, next piece, next piece. In 4 days, the highway was open. 4-lane highway.
Was not over water though, for the cars and stuff.
Probably was over water.
Was it over water?
Probably. I gotta look at that research and see if it was over water. Because I'm sure they poured the foundation before they took the bridge out, because they're not gonna, while the bridge is up there, who cares? They can go and pour actually the foundation, everything, have it ready to go, and just everything is pre-measured, pre-cut before it shows up there. They bring in the barge, everything on it, with all these lift machines, lift it up, put it in.
Because I know the concrete take 28 days.
Yeah, that probably was, the concrete probably was poured in advance, ready to go. That's under the water, and now we just gotta come and do the top, the part where we're gonna drive over. We don't care about that bottom part. You guys work on it on your own time. I wanna make sure the highway is not closed for more than 2-3 days. 4 days they had it done. Yeah. Okay.